good morning, good afternoon, good evening, depending on where you are. We are very excited to talk today about building reliable agents and the role of evaluations in that process, and in particular, asking this question of what's your agent's GPA? I'm Anupam Datta. I'm an AI research lead at Snowflake and formerly a professor at Carnegie Mellon University. And with me is Josh Reini. Josh is our developer advocate, working closely with me and our teams on these topics. So a few years ago, back in 2023, at that time, I had co-founded and was running a company called TruEra on AI evaluation, observability. And we did this experiment where we asked Claude, who are the founders of TruEra? And this is what it came back with. And if you look at this, it got a lot of the general outline correct. There were 3 co-founders, our backgrounds were in this in this neighborhood of AI and computer science. The topic of where TruEra was focusing was generally in the right neighborhood. But a lot of the other details are incorrect. We were not founded in 2014. We were founded in 2019. Sumesh is a real person and a good friend, but he was not my...
I can just kind of get started, and then when Anupam joins, we can kind of switch off, if that's okay. So I think what we saw right before the break is that when Anupam asked this question, who were the founders of TruEra, it got some things right. It was able to get that Anupam himself was the founder, but then both Somesh and Tomer mentioned here by Anthropic's Claude back in 2023 were a hallucination. And this is a really common issue across lots of different applications that were being built at the time, where the LLMs relied on their pre-trained knowledge, and when that didn't exist, they would hallucinate. And at that time, we came up with a series of metrics to start to understand that. And by 2025, a lot of these models themselves had solved this problem and were able to successfully answer questions like this. So here's a kind of analogous screenshot from 2025, where Anupam asked the exact same question, and it was able to get the question exactly right, along with citations around each of these, the founders and the facts that it's mentioned in the response. And this is really kind of a nice story of where the world of Gen AI has come from 23 to 25, is that our LLM responses can now be grounded in real evidence, whether that be internal company documents, website references, or things like that. In this case, we see a number of different references here that the LLM is making to back up its claim and provide facts that justify its answer. And this is one of the key metrics that we started working on all the way back in 2024 when we created TruLens in open source, is to actually evaluate the LLM's response and make sure that it's responding using this evidence. So how can we actually check and take the different LLM claims that the LLM is making and check those against evidence from the source? So that makes up one of the 3 metrics in what we started calling the RAG triad, being groundedness, answer relevance, and context relevance. Answer relevance telling us if this answer actually responds to the question that the user asked, and then context relevance looking to see if those sources that it's looking at are relevant to the query that was being asked. So how do we go from here to agents? So RAGs are kind of a relatively constrained construct. You often have a retrieval mechanism, and then a generation mechanism. And we can go a lot farther and be more flexible by compounding these different systems into an agent. I think the term or phrase compound AI systems was used a lot around a year ago, and then we've started to coalesce around calling them agents, but it's kind of much the same concept. So these agents will often start with planning. They'll maybe do some goal determination, intent determination to understand what the user is trying to accomplish, and then write down a plan, often explicitly, and saying, I need to call tool X and then to call tool Y. These agents will often make use of tools such as web search. They might even do retrieval in vector store, just like you saw in RAG, or they might call APIs or even call additional tools or MCP tools and take additional actions. Maybe they even write an email or in rare cases, even make a purchase or something like that. Agents also often use reflection to improve their response. So as they're executing, they can look back at the history of their different tool calls and the planning they've done, and they can reflect on how well they're performing so far, and then use that to better execute and choose future tools. Memory is also really useful here, looking back on the chat history with the user to do the same and really understand what the user is looking for so that the agent can best answer the question. And a new paradigm that's started to emerge also is multi-agent collaboration. So how can these different agents that are specialized in one particular task or one data source, how can they work together with new protocols like A2A to actually accomplish larger, more complex tasks? So if we focus down a little bit from agents into data agents, these are agents that are really focused on data sources. And what do I mean by that? We're connecting to different data sources. We're often understand the queries and break them down into relevant subqueries. We'll decompose and then figure out maybe some of these decomposed sub-questions need to be answered with data retrieval. Some need to be visualization. Maybe some require some other tool. And then these agents will provide insights or take actions based on that data. And these data agents are getting really widespread adoption. So in consumer, we've seen deep research gain a lot of traction within ChatGPT. And these are like very long running queries. They can take like 10 plus minutes and do a lot of research across the web to answer whatever question you throw at it. And then in enterprise, we have Snowflake Intelligence as one example that can answer questions across many different data sources, including structured with text is equal, unstructured doing search over unstructured documents, and then combine these different retrieval mechanisms to answer a pretty complex question. And how do these agents work in general? So there's kind of three concepts that we need to think about: the agent's goal, the agent's plan, and then the agent's action. So when the agent gets their question, the agent is going to first figure out what the intent of the user is. What is the goal of the agent that the agent is trying to accomplish? And then the agent will take that goal and break it down to a plan, often explicitly writing down what is the sequence of tools the agent needs to call in order to accomplish this goal. And then last, once the agent has written down this plan, it will execute and take actions and make the tool calls that are explicitly defined in the plan. And as the agent is executing, if it uncovers new information and new findings that require a replan to better answer the question and accomplish the goal, the agent is enabled to do that. And it can create a new plan and then continue the cycle.
Josh, I'm back. There was some internet glitch. I'm not sure what happened there, but
Awesome.
I can take over now if that's okay, and then I'll give it back to you for the demo. Thank you, Josh, for sharing the goal, plan, action process through which agents work. Let me do a quick example of this in action, and that'll set up the motivation for the Agent GPA evaluation framework. So here's an example of a question that one could ask a data agent like Snowflake Intelligence: what metrics are we optimizing for in our marketing campaigns? And when this question is received by the agent, the first step is for the agent to determine its goal. So you can see here, these are the thinking steps from the reasoning model, which the agent is powered with. And the agent is thinking, the user is asking about metrics that are being optimized for marketing query campaigns. This is a question about quantitative performance metrics and measurements. So I should use the query performance metrics tool to get information about the available metrics and the campaign performance data. So it has now understood its goal. It's starting to think about a plan to achieve the goal. And then the next few steps here makes the plan more detailed, where it has figured out that it should use some of these metrics and should query the performance metrics tool to understand what metrics are available and being tracked for campaign optimization. So you've gone from goals to plans. Next up is actions. Then the agent takes actions according to the plan. So on the left side here, you can see the observability execution trace of the agent. It had done some initial planning step that took about 4 seconds. Then it uses this tool called Cortex Analyst, which translates text to SQL. And it has come up with this SQL translation of what SQL queries to run to gather the information relevant for these marketing campaign metrics. And then it executes that SQL. You can see that takes about 1.2 seconds. And then once it gets these results and it reflects on them, and now it has a sense of what kind of data and what are some of the metrics that the marketing campaigns are optimizing for, like revenue generated, clicks, conversions, engagement rate, and so on. And at this point, after the reflection phase, it comes up with an additional replan, augmentation to its original plan. So it says that, well, it would be good for a bar chart to show these different metrics and their average values. It also observes that the scales are very different, so it has to be thoughtful about how to present. And then finally, the part of the plan here is to generate a chart to visualize the key metrics. And now the next few steps in the execution trace, you can see is after this planning step, the replanning step, which took about 5 seconds, it generated the chart and then the final response. So this is the final execution trace of the agent, and the final answer in this case would answer the question that was asked by the user. But you'll observe this alternation between planning and action. So original plan, text to SQL call, next planning step, and then a couple more actions to finish out the final task. So this observation of how agents go from goals to plans to actions led us to this insight that for agents to operate reliably, their goals, plans, and actions need to be aligned. Or dually, if goals, plans, and actions are not well aligned, that results in failure modes for agents. So that was the motivation for our Agent GPA framework, where G, P, and A stand for goals, plans, and actions, where our intuition here, or insight, was that we want a framework to look for misalignment between goals, plans, and actions. And that led us to this rich set of evaluation metrics. The first set of metrics sit between goal and actions and are checking, is the sequence of actions achieving the goal? So you can see here in this category are answer correctness, meaning is the final answer correct? Is the final answer relevant? Is it grounded? Meaning, can we trace it back to some, provide a citation back to a source? And any of these failures are failures of alignment between actions not achieving the goals. Next up are, at this intersection between goals and plans, we have plan quality, Plan quality is checking, is the plan that the agent has come up with, is that a good plan for achieving the goal? Is it going to actually achieve the goal? Is it going to do so in a way that is efficient? And tool selection is a special case of it, which is looking at, in order to achieve this task, is the agent making use of the right tools in the right sequence? So these sit here in this intersection between goals and plans, and is looking for misalignment between plans and goals. And finally, plan adherence, which sits here between planning and action, is checking, did the actions actually adhere to the plan or follow the plan that the agent come up with? If it doesn't, that would be a failure. And then tool calling is a special case of it, where we check if the agent called the tool in the right way, with the right parameters, in the right format. So that gives us these three intersection areas. And then we have a couple more evaluation metrics: logical consistency and execution efficiency, which sit at the intersection of all three. Logical consistency checks if there is any form of inconsistency between goals, plans, and actions. So for example, if the agent came up with a plan and then made adjustments to the plan without a good justification for why it adjusted its plan, that would be an example of logical inconsistency. Execution efficiency checks, is the agent taking the most efficient path for achieving its goal? Agents can sometimes wander around and do a lot of redundant actions, and then the costs add up. We want not just high quality, but also high cost, but also low cost and efficient execution in the process of executing agents. So all of these metrics are implemented as carefully prompted LLM judges and are available in open source in the TruLens project. So you're very welcome to go try it out. TruLens has a permissive MIT license, so you're also welcome to use it in your day-to-day work. We have found this to be quite useful and effective in our internal work at Snowflake as well. In terms of evaluation, I will mention two quick things, and then I'll hand it over to Josh to give you a demo. We evaluated this framework both on our internal agents like Snowflake Intelligence, but also on public data sets like Trail Gaia, which is a data agent-like data set. And we observed that the GPA judges were quite effective in detecting errors. There were three categories of errors: low impact, medium impact, and high impact. And across all three, we have much better numbers than this baseline, which was from a prior work by the authors of this benchmark data set. And overall average, we have the Agent GPA framework detects 95% of the errors relative to the 55% from prior work. And we also found that the GPA judges can also help with localizing the errors, not just detecting them, but showing the exact step which introduced the error. You can follow this QR code or URL to get the full results in our technical paper, which is on arXiv. It has a lot more details, additional experiments. We also have done experiments with SweBench, which is for a coding agent. So very different from a data agent, but also with promising results. With that, let me stop here, and I will hand it over to Josh to give you a demo.
Awesome. Thanks so much, Anupam. As I'm switching over, I will just take one question now. Daphne asked if there was any insight into what kind of errors to get the final 5% from the benchmark.
Sorry, say that one more time.
Yeah, Daphne asked if there was any insight to kind of close the gap on the final 5% in the trail benchmark.
Yeah, that's a very good question. So if you had noticed on that slide, the low impact errors were the ones where we missed, where the Agent GPA framework missed the most. A lot of them were fairly low level errors related to formatting and such. So we were focusing a bit more on like the macro, most impactful errors, but I think those could be captured by having more specialized judges in the in each of these categories, especially on goals, on like the action adherence to the plan. That should help with closing the gap.
Awesome.
I think we have a few hands up, but let's please put the questions in the Slack channel. We want to be mindful of folks' time, and so I'll hand, since we lost some time in the beginning because of technical glitches, let's have Josh go through the demo, and then we'll hang back and take additional questions. But please keep your questions coming in the chat.
Yeah, perfect. That
Josh?
Awesome. Yeah, thanks so much, Anupam. So here I'm jumping into the same agent that Anupam showed us earlier in slides, this marketing campaign agent. Just to show you a little bit about the agent, we have a few different sets of instructions. We have some instructions on response, along with orchestration, that tells the agent exactly how it should go about taking questions. And then we also have a few tools. We have Cortex Analyst that is doing text to SQL for us. We have Cortex Search, which is doing hybrid search on our unstructured documents. And then we have a custom tool to generate HTML reports when requested. So we can kind of ad hoc try this agent out right here. So we can ask something like, what campaigns have the highest ROI? And then the agent is going to follow this goal, plan, action sort of sequence as it executes. So you saw it first, it planned. Then it executed some SQL. Now it looks like it's doing some replanning. And then we get our response. And this is great. It's great to see that we get a response here. And it seems like it's pretty thorough, but it's kind of hard to tell on a one-off basis without kind of having some systematic way to evaluate this. So what we really want to do is create a data set here and then systematically evaluate it with some metrics so that we can understand how well our agent is performing and what are the problems it's having. So to do this, we can create an evaluation set over here. And I won't focus too much on kind of the details, but more the concepts here. So we can create a new evaluation run, which is just any invocation of our agent across all of the representative questions in our data set, which is hopefully representative of how our agent is going to be used in production. We want to choose the data set. So here I have the data set stored in a particular database. And then the key part I wanted to show you here is that there's two parts of the data set. So one is the query text, and then the second is the ground truth. So the ground truth is the expected sequence of tool calls that are expected for any individual query. And then the second thing is the expected response. So some of these metrics rely on this ground truth. So answer correctness is going to rely on that expected response that we have stored in our ground truth table. Our tool selection accuracy and tool execution accuracy is going to rely on the ground truth sequence of tools and tool use. And then the last metric I'll use in this evaluation run is logical consistency. And this is a reference-free metric, so we don't need any ground truth for this one. And the LM judge is just going to look at the agent trace and look for any inconsistencies or gaps in logic as the agent is executing. And then once I've set up my data set and selected my metrics, I can choose create here. And just to save some time so we don't have to wait on the agent to execute against all these queries and compute some metrics, I've already done this for us right here in this evaluation run. So here you see a completed evaluation run, and you see a full data set of executions across our data set. And then on the right side of the screen here, you see our evaluation metrics on the record or trace level. And we see 4 different metrics. We see answer correctness, AC, logical consistency, LC, tool execution accuracy, and tool selection accuracy. The headline metrics are pretty good. We can see that at the top, but there are some pretty bad failures here, which we can see in the red. So that might be something we want to focus on here. So let's take a look at one query where we asked to generate a report for the holiday gift guide campaign. And if we take a look at the tool selection accuracy metric here, I'll expand it so you can see a little bit better and zoom in. So here you see we expected only run one tool call just to generate a report. And instead we called 3 different tools. We called the query performance metric twice, and then we generated a report. So this was some unnecessary tool calling that we could have avoided when this is a relatively simple ask. And then the other query that I think is interesting here is this one that has low scores on 3 different metrics. So here we asked the question, which campaign type has the best engagement rate? And again, let's look at tool selection accuracy here. And here we expected 2 tool calls. We expected to do a text to SQL call with query performance metrics, and then we expected to generate the report. And we got the right tools, but we actually called this query performance metric tool twice. And perhaps with better instruction on how to call these tools and how to use them, we could have only had one query performance metric tool call here and been a little more efficient in this execution. So to solve this issue, I can just update my orchestration or planning instructions, which I'm going to do here. So here, I'm just going to create a new version of my agent and then add this additional section of instructions that it tells it to use as few tool calls as possible to answer the questions. And I give it some guidelines on how to choose, or how many tool calls to choose. So if there's one topic I wanted to just use one tool, 2-part questions can use two tools, and so on. And then once I've updated these instructions, rather than ad hoc trying to figure out if it's now performing better, I just want to create a new evaluation run so I can systematically validate to see if my agent is performing better than it was in the last version. So I've gone about the same process that I did before in creating this new evaluation run. And we see the full data set of how well our agent is performing. And you see our overall metrics are much better. And we don't have any of those agent failures now. So there's no scores in red on any of these queries. And you see our overall metrics are a lot better. And we can click on maybe some of the same queries that we saw before. So here we actually, I think we asked a similar question. We say which campaign type has the best engagement rate in 2024. And we have a better tool sequence here where we have a Cortex analyst call and then a Cortex search call along with our custom tool. So here we have actually distinct tool calls that are performing different purposes rather than calling the same tool twice in a row. So I think I'm much happier with this and I'm in general very pleased with the improvement of my agent overall across all these different metrics. So to just recap a little bit about the progress we made. So in the first version of our agent, we were able to test it ad hoc. We were able to try different questions, but what we really wanted is to create an evaluation data set to understand systematically how well the agents are performing and find different failure modes. We had identified a really clear failure mode that the agent was overcalling some tools. So we updated the orchestration and planning instructions so we can avoid that tool calling failure. And then we validated the improvement by creating a new evaluation run. So the demo I'm showing you is in Snowflake, but all of this core functionality with tracing and evaluation is also available in open source in TruLens. And we definitely encourage you to try it. I think you'll actually find even more metrics that I'm showing, including the ones Anupam showed in the slides in the open source. So definitely check that out. And I think now is probably a good time to go to questions. So I'll stop sharing.
Great. Thanks a lot, Josh. Maybe there are a couple of questions that are related to the demo. So why don't we take them quickly and then we can go over the other ones. So one question for you, Josh, is why did it call the same tool twice if the second tool call was not needed?
That's a good question. So maybe we can look back at the trace again and see what was going on. So here was the problematic trace. And we can look at, so in this first question, it's answering which campaign type has the best engagement rate. And then the second one, it's trying to get the campaign ID for customer acquisition campaigns. So if you kind of think about it, these two different text-to-SQL calls actually could have been combined in one if this first analyst or tool call successfully got that campaign ID that it really needs to answer the question. So that's something that could have been, this second tool call could have been avoided with better instructions on actually how to use this tool. So we could have actually gotten all of the information we needed just in one tool call instead of two.
Okay, good. So maybe we can take some of the questions. Let me try to go over some of them. So some of the questions from the top, one question was what happens when the reference sources contradict each other? How do we know the correct reference was used? That's a very good question. So in groundedness evaluation, you can think of this as two somewhat separable problems. One is with groundedness, what we are looking for is, are there references that support the conclusion? And if in a setting where there might be also sources that contradict the conclusion, then one option is to provide the supporting evidence and as well as provide the contradicting evidence, and then have like the human in the loop make the final call. And we actually see certain settings where this happens. So one concrete example from a couple of years ago was documentation for software, where documentation sometimes when documentation gets updated, then you have a new version. And the groundedness evaluations, because it has access to also the old version of the document, like the old version of the documentation, version say 1.0 might say one thing and version 2.0 might contradict it. So in that setting, there was a clear way to resolve the conflict because there is a kind of a temporal precedence where the new versions have higher priority over the older versions. But in some other settings, that may not be the case. So then it makes more sense to report both supporting evidence as well as contradicting evidence. The other related body of work here is, if you think about web search and such, there is a lot of work on identifying authoritative sources, right? So Google has historically, when Google came out with PageRank and or related things from IBM on web hubs and authorities, and over the years, there has been a good amount of work on identifying sources that are authoritative. So that's an orthogonal body of work that can also be looped in, where you could imagine that every source also has a authority score, and then the citation would typically look for more authoritative sources, and if there's contradictions, we'll highlight them, but also bring out that the higher authority sources are taking that kind of path. So I think that's part of the answer to that question. Another question was about, is this like the React style of design pattern for agents? Yes, React is the starting point for this goal, plan, and action kind of framework. It goes a little bit beyond React, and that the interpretation of the goal itself also is an important part of the story. And in something like Snowflake Intelligence, there are a number of additional artifacts like semantic views and so on, which are very helpful in understanding the intent of the query itself. But it is structurally quite close to React. How many planning stages do we need? That depends on the task. It's not fixed a priori, and that's the power of the method, where if the complexity of the task goes up, then the planning and replanning steps there might be more stages based on the complexity of the task. Is a specialized model necessary for SQL generation, or can general purpose models handle it effectively? Great question. General models work quite well for SQL generation. We have also done work. The AI research team at Snowflake has done work, and there's other work in the community showing that doing post-training on open source models can beat general purpose models on certain kinds of benchmarks. So a combination of starting with open source models like DeepSeek or Qwen, and then doing a combination of SFT and reinforcement learning. If you look at the bird leaderboards and spider leaderboards and so on, you'll see that some of the agents which are at the top of those leaderboards actually make use of more specialized models. But the general purpose models also work fairly well. So I think those are some of the questions. There are more. I'm just keeping an eye on the time. Josh, do you want to look through the questions and see if there are any other ones that you want to take?
Yeah, I'll look through the questions. Let me also just share the links for resources in the meantime folks can check out. So you can take a look at a link to the paper. I've also linked that in the chat earlier. You can take a look. We've got a link to the open source project TruLens, where you can see these metrics along with the tracing implemented in open source. And then Anupam and I also have a great deep learning course. We've got, I think, over 20,000 folks enrolled at this point. So would love if you want to take a look at that. It's a really great kind of hands-on way to try out some of these metrics and understand how they can help you improve your agent. Great. So taking a look back at the chat, it's one question, are you using the same LM or different one for judge? And also, is it inferior one or equally strong? So the LM that's executing inside the agent is totally independent from the one that is the judge. In this case, we're using a different LM. But the key thing I want to call out here is that the judge task is very different than the task that the LM inside the agent is doing, and we're not concerned about bias there. And then as far as like choosing a model for the LM judge task, I think it's not important in reference to the LM that's in the agent, but instead you should think about the complexity of the judge task. So for easier LM judge tasks like a relevance check, you can use a smaller, less powerful model. For more complex evaluations, such as our GPA evaluations that are looking at the entire agent trace, there can be a lot of complexity there, and it can be helpful to use a more powerful model.
Yeah, there's one question about, can planning go in infinite loop? Usually we have kind of a time bound on it, some kind of constraint, which could be based on time or number of steps, a number of iterations, as a way of making sure that if there isn't a good response within a certain amount of time, then it's terminated.
I think Dennis has an interesting question here. He asked if we expect evaluation will become a similar role to QA in traditional software, or if we expect engineers to continue owning evaluation. I can say my view, and then maybe Anupam, you can like say your view too. But from my view, I think it's really helpful for the developer owning the agent to also take part in the evaluation, because they really understand what are the failure modes of the agent and what they're trying to design for. And they can also really tighten the improvement loop if they actually own the evaluations themselves. But it's also really helpful to have a subject matter expert for the kind of end domain in the loop as well. So I could definitely see that also owning the evaluation piece, especially as the agent tasks get more complex.
Yeah, I agree.
There's a question from Harshada. How do you design metrics that stay robust as agents evolve?
I think that's a good question. I feel good about the metrics, about the framework, in that I think we have touched on, or the insight is somewhat fundamental in that if agents are going through this goal, plan, and action phases, then a lot of agent failures arise at the intersection of these phases, or misalignment between goals, plans, and actions. I think at a framework level, that feels like a very general insight and fundamentally quite robust and future-proof. If the architecture of agents and the details of how agents are built and so on can change, but I do think the goal, plans, and actions as the phases for how agents operate will stay robust for time. The specifics of the metrics might evolve. So for example, one thing we didn't get into too much here is tool-specific evaluations, which fall under the actions bucket in our Venn diagram. But there's a lot of diversity in the set of tools that agents can make use of. There's going to be thousands of tools. And for each of them, there'll be a custom evaluation. So the framework allows for custom evaluations, but there will, depending on the evolution of agents, the set of tools will grow and become very diverse. And so I think that is not something that you can nail down completely, and you just need a general custom framework to build evaluations per tool.
Awesome. I think this is a great session. I really appreciate everybody's engagement. It's exciting to meet so many folks that are excited about this topic, hopefully maybe even as excited as we are. So definitely continue engaging with us. Check us out in the GitHub to check out TruLens source, and would love to connect with you all further on this topic. So thanks so much.
Thank you.